Welcome to Topic 5 of the CSS full course, CSS Units. CSS units are essential in web design, defining the sizing and spacing of elements on a page. We'll be taking a deep dive into the various units available to us, from absolute units like pixels, to relative units like percentages and rems, and get a solid understanding of how to and when to use each unit type to build more responsive web pages. Let's start by exploring the basics of fixed and flexible measurements with absolute and relative units. We'll be discussing absolute versus relative units and the importance of relative units. So let's start off by talking about absolute and relative units. Relative units are essential for responsive web pages so elements can dynamically adjust for different screen sizes. Now, we briefly touched on absolute and relative units earlier on in the course in the CSS text topic. So let's quickly recap what we discussed there. We first spoke about absolute units. This is when the size is fixed and does not change in relation to parent elements. Examples of absolute units include pixels, points, inches, centimeters, and millimeters. Points, inches, centimeters, and millimeters are uncommon in web development. Point is an absolute unit that's commonly used in the print industry, and inches, centimeters, millimeters are units that are used in the real world. Now, throughout this topic, we're going to be looking at a whole bunch of relative units. However, the pixel, which is an absolute unit, is still used for specific cases. We're not going to be totally throwing it away. We are still going to be using it. So what are relative units? Relative units is when the size is based on the size of a parent element and adjusts proportionally to changes in the parent element. Common relative units include percentages, Ems, Rems, VH, and VW. And we'll be looking at each of these throughout this topic. Relative units are commonly used in CSS because they dynamically adjust depending on the screen size, which is really important for responsive design. That is, design that caters for all different screen sizes, like desktop, tablets, and mobile. So just to highlight the difference between absolute and relative units, I'm going to use this analogy. What you see over here is a photograph of how I proposed to my wife. We went out for a nice Mexican dinner and came back to her parents' house, where I got her family to put a whole bunch of balloons with string coming off them and attach photographs of us during the time we were dating. Yes, I was a bit of a romantic. Anyways, the reason this is relevant is because it's actually a great way for me to show you the difference between absolute and relative units. So here's the balloon with the string dangling off it and attaches a photograph of me and my wife. We're going to say the balloon is the parent, which has this height, and the photograph is the child, which has this height. Now, if I increase the size of the balloon, we can say that the parent increases. Now, the balloon increasing in size has absolutely no effect on the photograph increasing in size. It remains the same size, so there's no change in the child. This is how absolute units work. We can adjust parent elements without having any direct effect on child elements. I now want to compare this to putting an elastic band around the balloon. The balloon is this height, and again, we're going to call it the parent. And the elastic band is currently this width. And in this case, the elastic band is the child. Now, when we blow up the balloon and increase its size, the parent increases. But also, the elastic band has now increased, so the child increases. This is an example of relative units. The size of the parent directly impacts the size of the child. So let's see relative units in action. On the left, I have a desktop design, and on the right, a mobile design. On the desktop view, you can see the main container with the text and buttons has a lot of space left and right. However, on the mobile design, you can see now there is no space left and right, so the main container widens. Another example of relative units is this space between the callout at the top, number 1 team building software, and the main heading. This would be something like padding. And while a little bit harder to see, on the mobile version, the padding reduces to tighten up the content on the mobile to improve its readability. And something very noticeable is on the desktop view, our main heading is very large, whereas on the mobile view, the font size reduces. So here are 3 really good examples of where we would use relative units: on containers, box model properties like margin and padding, and font size. And we'll be looking at how we apply relative units to each of these and more throughout this topic. So let's start building out the summary card for this topic, CSS units. Now, we haven't actually looked at any relative units yet, so all I want to do is list out common places we continue to use pixels. pixels are still used in the following areas: border radius, border, letter spacing, logos and icons, max width, and shadows, which we'll be looking at later on in this course. Besides the max width property, all of these properties tend to be much smaller values. For example, it's not common to have large border values, something like 5 or 6 pixels. Because these values are so small, we continue to use the pixel because using relative units really has no impact on them. Now, over the next few chapters, we'll continue to add to this summary card of common use cases of each CSS unit. Now, inside our Quill project, I just want to highlight some of the areas that absolute units are causing some issues. We're going to see this by opening up DevTools and clicking on this device toolbar over here. I'm just going to make some more space. And let's start with this text up here. If I reduce the width of the browser, so I'm moving towards a mobile view, you can see this text is just way too large. And that's because we're using an absolute value of pixels. We need our text size to reduce as the size of the browser reduces. Another issue is that the content is butting up right against this left edge. You can see that over here, and other headings and paragraphs over here. This doesn't look great. We need a little bit of space left and right. You can also see our images are not reducing with width. They're staying the same size. We need our design to reduce the image sizes as the width of the browser reduces. And the final issue, which we've seen before, is that our call to action over here is looking very weird because of the left padding over here. So we also need to fix some spacing issues like padding and margin. Now, throughout this topic, we're going to be using relative units to make our homepage more responsive. Next up, let's take a look at our first relative unit, percentages. We'll be discussing what are percentages design guidance, and common percentage value use cases. So what are percentages? A percentage is a unit that is always relative to some other value. There are two main use cases in CSS. The first is relative to a parent, and these are commonly used on CSS properties like width, height, margin, and padding. Using percentages relative to a parent is very common. Looking at an example of this, in green I have a container. Its width is 1000 pixels, and its height is 600 pixels. If we were to place another container, like a div, inside of this container, the red container is now a child of the green container. We could then set the width and height of this red box relative to its parent dimensions. So we could do something like this. We could set the height of the box to 50%, which would be 300 pixels, 50% of 600 pixels. And we could set the width to something like 40%, which would be 400 pixels, 40% of the 1000 pixel width of the parent element. So we're using percentages for the width and height of our child element, where the final pixel value is being calculated based on the width and height of the parent element. Another use case of percentages is relative to the element itself. You can use this on a property like line height. I do just want to flag that there are very few elements you can do this with, so don't worry too much about it. Using percentages relative to a parent is way more common. But let's look at this. If we have some text, this text would have a height which is determined by its font size. Let's say it has a font size of 20 pixels. We could then apply line height as a percentage of the element itself. So let's say 200%, which would be 40 pixels. We're using the font size of 20 pixels and doubling it to apply line height of 40 pixels. Let's check these out inside VS Code. So I've got a blank index.html file, and I've gone ahead and connected a blank style sheet app.css. Inside the body, I'm going to create a div, and I'm going to nest another div inside of this. We'll give the parent div a class of parent, and we'll give the child div a class of child. In app.css, I'm going to select the parent. I'm going to give it a height of 500 pixels, and for now, let's give it a width of 800 pixels. And let's give it a background color of light blue. Let's go and select the child. We'll give it the same height of 500 pixels. For now, I'm going to give it a fixed width of 600 pixels. And let's give it a different background color of light salmon. All right, let's check this out in the browser. Okay, so we have our blue parent over here and our salmon colored child over here. As we know from the HTML markup, the salmon colored box is a child of the parent. Now I want to go change the width value of the parent. Let's make it 1000 pixels. I'm going to refresh. You can see that the parent width has increased And as expected, nothing's happened to the child because we're using absolute units. I'm going to change this back to 800 pixels. And now, instead of width 600 pixels, let's go change this to 50%. I'll refresh, and now you can see what's happened. The child element is now 50% the width of the parent, which would be 400 pixels. Let's check this out inside DevTools. I'll select the child element, and on the box model, you can see it's 400 pixels wide. Now here's where the magic happens. If I come and change the parent width, let's now make it 1000 pixels, the width of the child will still be 50%. So let's refresh. So you can see now that the width of the child has gone to 500 pixels. That is, the child width is directly proportional to the parent width. Let's now have a look at the other case where we could use percentages relative to the element itself. And as I mentioned, this is less common, but I still want to show you. I'm going to go remove these divs, and I'm just going to add an h1 tag. Let me put some text, some text. In app.css, I'm going to remove these styles, and I'm just going to select the h1. Let's give it a font size of 20 pixels. I'm going to give it some background color of light green, and let's apply a line height value of 200%. So we would now expect a line height value of 400 pixels. Let's check this out in the browser. So you can see over here is our text, and there's height above and below. And if we inspect this in DevTools, we can see that the height of the element is now 40 pixels. That is 200% or double 20 pixels. So let's now take a look at some percentages guidance. Percentages are used in conjunction with max width on main containers so that the web page is fully responsive. Let's have a look at this page over here. We can see the container in red, and this container would have a max width property where the value would still be in pixels, which is very common to do. When we reduce the width of the browser for a viewing experience on tablet or mobile, we want to ensure the content inside the container is not right up against the edge of the screen on the left and right. If you remember, the max width property just sets the maximum width, where the content can still reduce. So we need a way to ensure that there's still space left and right of the main container. We have our body over here in green, and you can see our container in red. So in addition to the max width property, which is mostly there to control maximum width on larger screen sizes, we apply a percentage of the body when the screen is smaller to prevent the content going right up to the edges. So you can see we have some spacing on the left and right of the main container. So let's see this in action. I'm currently on this home page on my desktop, and you can see there's a lot of space left and right, as all of this content is in a container. And this is being controlled by the max width property. Let's check it out in DevTools. Over here we have this div with the class container. So I'm going to click on that. The container has a max width of 75 rems. We're going to be talking about rems soon, which is a relative unit. Now I'm going to come turn this max width off, and you'll see that the content stretches much further. The max width is here to ensure that on larger screens like a desktop, the content inside the container doesn't stretch too far horizontally. I'm going to come and reduce the width of my browser, and you'll see that the container on the left and right reduces in space, because on smaller screen sizes like a mobile, we need our content to take up more space, as space is limited on smaller screen sizes. However, you will note that there is still a bit of space left and right, and that's there to avoid the content butting up left and right on the edge of the browser, because that would not be a good viewing experience. So max width has nothing to do with this now. This is now controlled by a percentage value. I'm going to go back to the full screen. On the container, if I turn width 95% off, you can see nothing happens on the desktop view. I'm going to turn it back on, and let's go toggle the device. I'm going to reduce the width so we get to a device like a mobile. I'm also just going to remove some styles from this app media. This is called a media query, and it's something we'll be discussing later on in the course. I'm just going to scroll down on the page to this heading and paragraph here. Watch what happens when I turn the width off. You'll see the content moves a lot closer to the left and right of the screen. I'm just going to toggle it on and off so you can see it again. Now I'm going to turn the width back on, and I'm going to change it to another value, like 70%. And you can see now that there's a lot more space left and right. This is not something you would do, as this doesn't look great, but I just wanted to show you that for smaller screen sizes, we now introduce the width property in addition to the max width property, but we use a percentage value on the width to ensure that there is still a container which has space left and right on smaller devices. Now, this is something we're going to be implementing on our Quill project, and I'll be discussing it in more detail there. So don't worry too much about it now. I just wanted to show you that percentages are commonly used on a main container, and they're specifically used to ensure that there is still a container with spacing left and right when our page is on smaller devices like mobile. So let's look at some more percentage guidance. Percentages are used in conjunction with max width on standalone images so that the web page is fully responsive. Here's the Notion homepage, and you can see we have this large standalone image over here. To avoid the image stretching too wide on desktop screens, we apply the max width for larger screens. Now this works well on larger devices like a desktop computer, but there is some extra work we need to do for mobile. On the mobile device, we have our main container here in green, and for our image, in order for it to be responsive, we need to also set the width to 100% on smaller screens so the image scales to the full width of the container. So on this image, we'd have both the max width property, which is there to prevent the image stretching too wide on larger screens, and we would also apply width as 100%. And this ensures the image reduces in size as the width of the browser reduces. Now, just a quick reminder about why we need to do this. It's because an image is an inline element. So we're going to be looking at an inline element reminder. Inline elements will extend beyond the browser when it is narrower. So let's say, for example, we have our image with a max width of 1200 pixels. We have our browser, which is currently at 800 pixels, less than the max width of 1200 pixels. For an inline element like an image, it doesn't scale down like a block element would. It extends beyond the width of the browser, so it would remain at 1200 pixels. Now, one thing I want to highlight is that for standalone images, we're applying a width value of 100%. All that this is doing is ensuring that the width of the image scales at the same proportion as the width of the main container. Now, a block element would do this automatically, but for inline elements, we need to explicitly set width as 100% to ensure that it does scale down as the width of the browser reduces. I also just want to note that in the previous guidance, we were setting main container widths to a value less than 100%. That was to ensure that there was space left and right of the main container. In this case, we're setting the image to exactly 100%, so it scales in direct proportion with the main container. There are going to be quite a few percentage values flying around as we move through this guidance. Towards the end of this chapter, I am going to provide a summary of the different values we use in the different use cases, so just stick with me. So let's check out an example of this behavior. So I'm on this web page here, and if I scroll down, we have this large standalone image. As I reduce the width of the browser, you can see that the image scales down. I'm going to extend the browser back to the full width of my screen, and let's open up DevTools and see what's going on here. I'll select the image, and you'll see we have this max width property of 1012 pixels. I'm just going to turn that off, and you'll see the image goes quite a bit larger. So again, the max width property is there to ensure the image doesn't scale too large for bigger screen sizes like a desktop. I'm just going to pop it back on. You can also see over here the width property set to 100%. I'm going to turn that off, and let's see what happens as we reduce the width of the browser. You can see the image doesn't reduce in size now. And as I explained earlier, because an image is an inline element, it now overflows, and I can scroll right on the page to see the image. So that's what the width 100% is doing. It's ensuring that as you reduce the width of the browser, the image scales in the same proportion. So let's turn it back on, and you'll see now the image is scaled nicely. The next percentage guidance is that it is common to set images inside a grid or flex container to 100% so it fills the cell and adapts responsively. So far in this course, we haven't looked at grid or flex, and we still need to learn about it, but I did just want to provide this guidance now. On this page, we have a grid layout, shown by these two green boxes. The grid layout is 2 columns and 1 row. The image on the right is inside a grid cell, which acts as a container. And as you can see, the image nicely fills the container. And that's because we're setting a width on the image to 100%. 100% of the parent element, that is, its container. So let's go check out an example of this. So I'm on the Notion homepage towards the bottom. What we have over here is a grid layout. We have 2 columns and 1 row. Let's open up DevTools, and I'm going to select the image in here. You can see the width is currently set to 100%. I'm going to turn that off, and you'll see the images go huge. I'm going to open the image in a new tab, and you can see this is the actual size of the image. In order to scale it inside this grid cell, we need to set the width to 100%. Another example of this is using these icons over here. This is a much larger grid. It's got 7 columns and 3 rows. I'm going to go inspect the image. I'll click on this one here. And again, you can see we have width 100%. Let's go check out the actual size of this image. I'm going to right click and open the image in a new tab. You can see it's quite large. Coming back to this page, if I turn the width 100% off, and I'm also going to have to turn the height 100% off, you can see the image disappears. And that's just because it's gone huge inside that container. And all we're seeing is the top left of the image here. So it just looks like a white box. So again, setting width 100% ensures that the image nicely fits inside a grid cell. For the next piece of guidance, there are cases when you want to set a button width to 100% so it fills its container and adapts responsively. Let's check in this login page over here. This login form has a container shown in green around the headings, buttons, and inputs. We have buttons at the top over here and the blue button down here. And as you can see, the button stretches the width of the container. And in order to achieve this, we're applying a width of 100%. Again, the parent element here is the container, and we want our button to stretch the full width. So we apply width as 100%. That is 100% of the container width. Let's check this out in the browser. So I'm going to open up DevTools, and I'm going to grab this button element. You can see over here, width is set to 100%. Let's turn that off and see what happens. Now, because a button element is an inline element, we know that it'll just occupy the width of the content. And we can see that with this blue box. So to visually enhance this form, we want to stretch the button the full width of the container. You can see in blue over here. And again, that's done by setting a width as 100%. All right, the last piece of percentage guidance. Percentage values are used for fully rounded corners as pixels require manual calculation. I mentioned in the border radius chapter, we would later be changing our pixel values to percentages. Now, we often want fully rounded corners on elements like buttons and images. Let's say we have an anchor tag over here. Its height is 120 pixels, and we set a border radius of 60 pixels. I'm setting it as 60 pixels, as that's half the height. The way this works is we get a radius of 60 pixels inside our circle, and the sections in red are effectively cut away, which leaves us with a pill shape like this. If we had an anchor tag, which was 40 pixels, in order to get fully rounded corners, we would set a border radius of 20 pixels, again half the height. And the same thing happens. We get a radius of 20 pixels, and the bits in red are cut away. So in order to get fully rounded corners, the border radius is half the height of the container. So as you can see for pixels, we manually have to calculate half the height in order to apply a border radius, which gives us fully rounded corners. But using percentages is a lot more effective. Let's say we have the same anchor tag over here, and we now apply a border radius of 50%. We also have the same smaller anchor tag here, and again, we apply a border radius of 50%. So now the border radius is calculated automatically as half of the container. We don't need to manually work out the border radius. And this gives us the same result, fully rounded corners. All right, we've looked at quite a lot of guidance and had a lot of different percentage values flying around. As promised, I've created a table of common percentage use cases. Just to help summarize this, the first piece of guidance we looked at was for main container. This had a max width property to ensure the content in the container doesn't stretch too wide on larger screens. And we would also apply a width of a value less than 100% to ensure that on smaller devices, the container still had space left and right. We looked at a standalone image. This also had a max width, so the image didn't stretch too wide on larger screens. And we would also apply a width of exactly 100%, so the image scales proportionally as the width of the browser reduces. We looked at images in grids. This just had a width of 100% to ensure that the image filled the grid cell. We also looked at full width buttons, and we saw this used in a form to ensure the button stretched the width of the form. And to achieve that, we applied a width of 100%. And the final case we looked at was rounded corners. And to achieve this, we apply a width of 50%. So let's wrap up this chapter by continuing to add to our CSS units summary card. In this chapter, we looked at percentages. The common use cases for percentages was on main containers, images, and border radius. Now you can see border radius is used both in pixels and percentages. We use percentages specifically when we want fully rounded corners, and we use pixels for border radius when they're not fully rounded. So let's go and apply percentages on our Quill homepage. The first place we're going to apply them is on our main container, so that when our page reduces in width, there's space left and right. For us, the parent element is the body tag shown in green, and we have our main container here in red, where we will now go and set a width as a percentage value less than 100% to ensure that as the browser reduces in width, we have that space in white left and right. So let's jump into VS Code and add this to our CSS. So I'm back inside the index.html file, and you can see our main div here with the class container. This div is a child of the body tag. So applying width with a percentage value here will reduce its width in proportion to the body. And the body is just the full width of the page. Let's head over to app.css. I'm going to scroll down to my global styles. And over here we have our container. In a previous chapter, we already set the max width at 1200 pixels. And that's there to ensure that the container doesn't go wider than 1200 pixels on larger screens. I'm now going to go at a width of 90%. And again, this will ensure that when the width of the browser reduces, there's still some space left and right. So let's check this out in the browser. So to see the effect of this, I'm going to go reduce the width of the browser. And as I'm reducing the width, you can see we still have some space left and right. And this is being achieved by having the width set to 90%. I'm going to open up DevTools, and I'm just going to turn the width of 90% off, just to show you what happens. So now again, I'm going to reduce the width of the browser. And as you can see, the content is butting up right against the left edge, which just doesn't look great. So that's what that width 90% is doing. The entire container is 90% the full width of the page. You can see if I go on the body, the current width is 892 pixels. And when I click on the container, its current width is 802 pixels. 802 divided by 892 is 90%. So the remaining space, 892 minus 802, which is 90 pixels, divided by 2, 45 pixels, would be left and right of the main container you see now. And again, just to drive this home, the max width property is there just to ensure that on larger screens, like what I'm on now, the content doesn't extend too far. If I untick this, for larger pieces of content, like this paragraph over here, you can see it just doesn't look great. It's just too wide. Setting a max width on the container ensures all the content is nicely contained within 1200 pixels for larger screen sizes. Now the second thing we need to do is add a width 100% onto our images. We effectively want to reduce the width of the image so it's less than the max width and stretches to the container edges on smaller screens. I'm back in the app.css file, and I'm going to scroll down to the features section where we have our feature image. The image currently has a max width of 400 pixels, and not so long ago, we actually already added in the width property of 100%. I did this before we knew anything about percentages, but I had to do it back then in order for the image to scale down. But now you'll have an understanding of why we did this. It's because images are inline elements, and if we didn't add the width of 100%, the image's width would remain at 400 pixels, so that when the browser reduces less than 400 pixels, the image would overflow. Applying width 100% to an inline element is essential to ensure that it reduces proportionally as we reduce the width of the browser. So let's check this out. So I'm going to come and inspect the image, and you can see max width of 400 pixels and a width of 100%. Again, the max width is there just to ensure that the image's maximum width is 400 pixels. If I turn that off, the image goes huge. You can see if we look at the box model here, the image is currently 400 pixels. The browser width is 470 pixels. Watch what happens when I reduce the width of the browser. You can see the image is reducing in width. If I turn this property off, you'll see the image scales back to 400 pixels. And again, that's because it's an inline element. And an inline element, when you apply max width, will just be that width, when less than the max width you set. So because we're less than 400 pixels, the image is just set at 400 pixels. In order for it to scale down, we have to explicitly set width as 100%. Now it's time to dive deep into scalable units that help make text and layout more responsive with Rems and Ems. we'll be discussing what are Rems and Ems, and we'll be looking at Rems and Ems design guidance. So what are Rems? Rems are a unit that is relative to the root element's font size and are the key ingredient for creating responsive web pages. Now, before we dive in, I just want to highlight Rems are really important. They are the primary driving force of making our pages responsive. That is, scaling our content for different screen sizes. So this sentence may not be the clearest, so let's break it down. We'll be talking about the root element first. As a reminder, in our HTML document, we have this HTML tag, which we call the root element. Back in the HTML full course, I spent a chapter on document structure. And you can see over here are these HTML tags. This is the root HTML element which wraps all other elements. It's the same as a book cover wrapping all the pages. In HTML, it's the tags that wrap all the other content. Now the font size of the root element is 16 pixels. And what we're going to see now is that we can size different elements based on the root element's font size of 16 pixels. So let's look at an example of this. I've got over here an anchor tag with different properties. The first property is the font size of the anchor tag, which is currently set to 2 rems. So this font size would be 2 times 16 pixels, which equals 32 pixels. Again, the 16 pixels is coming from the root element's font size, which is 16 pixels. We can also use rems on non-font size properties. So for example, the padding of this anchor tag is currently 0.5 rems, which would be equal to 0.5 times 16 pixels times 8 pixels. Again, the 16 pixels is coming from the HTML root element, which has a default font size of 16 pixels. The last declaration, margin bottom, has a value of 3 rems. This is 3 times 16 pixels, which is 48 pixels. Alright, so you're probably thinking right now, this is just really confusing. What is all this extra work of using this rem value, which is dependent on the root element's font size, and then I've got to multiply numbers by it? Why can't I just put my values like 32 pixels, 8 pixels, and 48 pixels? And I agree with you, it does seem really confusing. But let's go play around in VS Code to get a taste of why Rems is so powerful. Alright, I've gone ahead and created this index.html file. I've got an h1, a paragraph, and an anchor tag. I've also linked a style sheet, which is currently empty. So let's head over to app.css and add some rem values to our different properties. I'm going to select the h1. Let's apply a font size of 3 rems, which again is 3 times 16 pixels, which would be 48 pixels. Let's apply a margin bottom of 2 rems, which is 2 times 16 pixels, or 32 pixels. Let's grab our paragraph. We'll give it a font size of 1.5 rems, so 1.5 times 16 pixels, which would be 24 pixels. We'll give it a margin bottom of 1 rem, so 16 pixels. I will grab the anchor tag. We'll give it a padding of 2 rems, which is 32 pixels. Let's give it a background color of light blue. And just so that the padding applies correctly, we're going to change the display property to inline block. And just as a quick reminder, that's because an anchor tag is an inline element, and for box model properties like padding to apply properly, we need to change it to inline block. Alright, so let's check this out in the browser. So you can see the different elements over here. Let's open up DevTools, and let's inspect the heading. You can see it has a font size of 3 rems and a margin bottom of 2 rems. Looking at the box model down here, you can see the margin bottom is 32 pixels, 2 times 16 pixels. If I head over to Computed, you can see the font size is 48 pixels, which is 3 times 16 pixels. And again, just to really drive the point home, all of these values are being calculated off the root element's font size. The default font size of the root element over here is 16 pixels. Now 16 pixels is not the nicest value to work with, so we can actually change this value. Just to show you this, if I make some space here, select the root HTML element and give it a font size of 16 pixels, I'll refresh and you'll see nothing happens. And that's because the default font size of the root element is 16 pixels. Now, as I mentioned earlier, I do want to give a bit of a taste of why Rems is so powerful, because at the moment, it just seems like a lot of work. In a later topic, we're going to be learning about media queries. And what media queries allow you to do is apply styling for specific widths of your page, which can be used for specific screen sizes, like mobile, tablets, and desktops. So for different screen sizes, what we're going to do is actually change the font size of the HTML root element. So for example, on a mobile, we might want our root element's font size to actually be 8 pixels. If I refresh the page, our font size, margin, and padding all dynamically updates by changing a single value. That is, the font size of the root HTML element. And for larger screens, we might set it to a value like 20 pixels. I'll refresh, and you'll see all the values dynamically update, all based off the root font size. Alright, I'm just going to go change this back to the default font size of 16 pixels. Now the default root element font size of 16 pixels is not the nicest value to work with. But let's go and see how we can make our lives a bit easier. Working with a base 10 pixels for rem units makes it simpler when thinking about sizing elements. My advanced maths is pretty good, but my basic maths sucks. So when I'm thinking of values, to have 16 as my base unit to multiply with fries my brain a bit. But 10 pixels is much easier to work with. So what we can do is inside our CSS file, we can select the HTML root element. So it's fixed at 10 pixels, which means one rem now equals 10 pixels. So let's go add this in VS Code. So I'm back inside our app.css file, and I'm just going to go update the root HTML font size to 10 pixels. I'll refresh, and you can see straight away all these elements adjust. Now the font size is 3 times 10, which is 30 pixels. Just so that we can use this new value, let's go change the font size to be 5 rems, which would be 5 times 10 or 50 pixels. Let's go open up DevTools just to confirm this is the case. I'll select the heading. You can see a font size of 5 rems. Heading over to Computed, we can see a font size of 50 pixels. I can also confirm on the HTML root element, we can see the font size of 10 pixels. And if I go to Computed, the font size is 10 pixels. So that's now the base unit we're working with. Now working with 10 pixels is certainly a lot better, but we do need to account for one more thing. What I want to show you is that your browser has a default font size it's using. Inside Chrome, I'm going to click these 3 dots. I'm going to head over to Settings. I'm going to go to Appearance, and you can see over here font size. This is currently set to medium, which is recommended. Now medium is 16 pixels. Looking at some other values, very small is 9 pixels, small is 12 pixels, large is 18 pixels, and very large is 24 pixels. Now I just leave my screen at medium, but whenever I grab my mum's laptop or phone, the text is seriously massive. It takes about 10 times longer to scroll through a page when looking at something on her phone. So to make it easier for her to read, she's using large or very large as her font size. Now the problem with setting font size at 10 pixels overrides those font sizes in the browser, which means that if someone were to go adjust the font size in their browser, like my mum, it just wouldn't scale accordingly. So to fix this, we instead set a font size of 62.5%. So where does this number come from? Well, we want our font size to be 10 pixels. All I've done is divide 10 by 16, which is 62.5%. 10 pixels is the value we want for a medium screen, but in the browser, the medium screen is set at 16 pixels. So what I'm doing is I'm effectively taking 16 pixels, which is the browser's font size, and multiplying that by 62.5%, which then gives me 10 pixels. And using a percentage value like this means we can use the different font sizes and just apply 62.5% to each of them. So this will scale if the user updates their browser font size. Looking at some mathematical examples, for medium, 62.5% times 16 pixels is 10 pixels, which is the value we want. And for very large screens, 62.5% times 24 pixels is 15 pixels. Again, the 24 pixels comes from the very large font size. So by using 62.5% for the different font sizes in the browser, we're multiplying each of them so that if someone were to go change their browser font size, everything still scales nicely. So let's go and update that inside VS Code. I'm just going to change our 10 pixels to 62.5%. If I refresh, nothing will happen. But now we've ensured that if the font size of the browser changes, this will scale accordingly. And just to demonstrate this inside the browser, let's go to the settings. I'll go to Appearance, For the font size, let's change it to very large. You can see the text goes very large. It's taking the browser's very large font size, which is 24 pixels, and multiplying it by 62.5%. Let's go change it to very small, and you'll see everything goes much smaller. The very small font size value is 9 pixels, so it's taking 9 pixels and multiplying it by 62.5%. All right, I'm just going to change it back to medium, and I want to show you what happens if we left this at 10 pixels. As you can see, there's been no change because 10 pixels is the same as 62.5% times 16 pixels, which is the medium case. But watch what happens now. If I go change this to very large, there's no change. And if I change it to very small, there's also no change. And that's because doing this is overriding the font sizes you set in your browser. So that's why using a percentage value is a lot better. Let's now take a look at some Rems guidance. Rems are commonly used on font size, margins, and paddings to create fully responsive web pages. I have this homepage on the left over here. We have some padding applied above the main heading, and you can see the font size is quite large. Looking now at the mobile version of this page, the padding over here reduces, and the font size also reduces. And as I've mentioned, when we learn about media queries later on in the course, all we're going to be doing is changing the font size of the root HTML element for different screen sizes, which will automatically adjust the font size, margin, and paddings for different screens. Let's now look at Ems. Now, Ems are not as frequently used as Rems, but we do need to go through them, as you will see them out there in the wild, and you also may want to use them in your own project. Ems is a relative unit that is more context-specific compared to Rems. When I say context-specific, I just mean closer. As you know by now, inside an HTML file, you can have many levels of nesting. Rems are relying on the root HTML element, which could be many nested layers above the element you're styling. Ems are not based on the root element. They're based on an element much closer to the specific element that you're now styling. Now, there are two main use cases of Ems. The first is for typography, where the element you are styling is relative to the font size of the parent. Properties you would use include font size, align height, and letter spacing. And again, I really want to highlight that we're relative to a parent now, and not the root HTML element. Our reference point is much closer or context specific. So let's go play around with this inside VS Code. All right, so I've gone ahead and set up a new index.html file. I've created a div, which has a class feature1. I have an h1, which has a class feature heading. I have a paragraph, which has a class feature paragraph. And I have an anchor tag with the class feature button. So let's move across to app.css. I'm going to select feature1, which again is our parent element. And I'm going to set its font size as 10 pixels. I'm going to select the feature heading, and I'm going to give it a font size of 2ems, which is 2 times the 10 pixels. As we discussed earlier, Ems is based on a parent element's font size. Because I'm setting this parent's element font size to 10 pixels, the font size of the heading will be 2 times 10, or 20 pixels. Let's go set some other properties nested inside the div. We'll select the feature paragraph. Let's give it a font size of 1em, so 1 times 10, which is 10 pixels. And let's select the feature button, which is that anchor tag. We'll give it a font size of 0.5ems, 0.5 times 10, which is 5 pixels. Let's also just give it a background color of light blue. All right, let's check this out in the browser. So you can see our heading, paragraph, and anchor tag over here. Let's just go confirm their sizes. I'll open up DevTools. I'll select the heading. You can see its font size is 2ems. And if I go to computed, you'll see the font size is 20 pixels. That's 2 times 10 pixels we set in our parent element. Now, if I go change the font size of the parent element, so let's go make it 20 pixels, you'll see all the values will double. So now the font size is 40 pixels of the heading. Now, just to really highlight that Ems are based on a parent as opposed to the root element, let's go back into index.html. I'm going to copy this and paste it here. And I'm going to update this class to feature2. Inside app.css, I'm just going to change this back to 10 pixels. And I'm going to go select feature2 and give it a font size of 20 pixels. And these styles are still being applied to the content inside both feature1 and feature2. So let's check this out in the browser. So what we can see here, because the feature1's container has a font size of 10 pixels, whereas our feature 2 container has a font size of 20 pixels, the elements in here are effectively double the elements in here, because features 1 font size is 10 pixels, whereas feature 2's font size is 20 pixels. Now you just wouldn't be able to do this with Rems. Just to demonstrate this, I'm going to remove these styles. I'm going to get our HTML root elements. I'm going to set its font size to 10 pixels. And then I'm just going to update these all to Rems. If I refresh, you'll see both feature 1 and feature 2 are now the exact same. And that's because they're all being based off the single HTML root element. Whereas before, I was able to size the features differently based on the parent element's font size. Now, in addition to typography, we can apply Ems to other properties. And these are relative to the font size of the element itself. Common properties include width, height, margin, and padding. That is, box model properties. Let's play around with these in VS Code. I'm back inside the index.html file we were just in earlier. I'm going to go remove all of this. I'm just going to add a single anchor tag. For now, I'll point it to Google. I'll just have the text, click me. Inside app.css, I'm going to remove all these styles. I'll select the anchor tag. Let's give it a font size of 50 pixels, padding of 20 pixels, top and bottom, 40 pixels left and right. Let's give it a border radius of 20 pixels. Let's give it a background color of light coral. And for the box model properties to display properly, we need to change its display property to inline block. All right, let's check this out in the browser. So as expected, we have a button component. Now this is obviously quite a large button. If I had a smaller button in the application and I wanted the font size to be 10 pixels, if I only change the font size and refresh this, you'll see this just looks quite bad. There's way too much spacing around the element. So instead I can do this. So let me first just change this back to 50 pixels. So a better approach would be allowing us to scale the button based on the font size. So to do this, we can use the font size of the anchor tag set here and apply M properties to the padding and border radius. And that way, when we change the font size, these two properties will scale accordingly. So for the padding, we have a reference font size of 50 pixels. For 20 pixels, we would need to change this to 0.4 M. 0.4 times 50 gets us back to 20 pixels. For 40 pixels, this would be 0.8 M. 0.8 times 50 pixels gets us back to 40 pixels. And again, 20 pixels is 0.4 M. So if I refresh, there won't be any changes. But watch what happens as I change the font size now. Let's go to 20 pixels. I'll refresh, and you can see the button is scaling correctly with the font size. The padding and border radius has scaled nicely. So we can put any font size value we want here. Let's go make it huge at 100 pixels. You'll see again, the proportion of the border radius and the padding top and bottom is scaling with the font size. So let's now take a look at some Ems guidance. Ems provide a higher level of precision for styling smaller components, as sizing is based on font size of the element itself. So like we just saw, we can have button padding based on the font size of the button itself. Now Ems do provide a lot of precision, but the truth is, using Rems will make very little visual difference. In our Quill project, we're only going to be using Rems. And I suggest when you start out, you also just use Rems. When you become a bit more advanced with CSS, and you really want precision styling, feel free to use Ems. And just to show you that using Rems is totally fine, let's take a look at this application. I'll open up DevTools, and let's go click around on some different elements. We'll click on this heading, and you'll see its font size is set at 3.7 Rems. If I go to a component like a button, which is a good candidate for using Ems, you'll see again, box model properties like border radius and padding are still set in Rems. So here's an example of a professional working application that's just using Rems everywhere. And as I said, we're going to be doing the same, and I wouldn't worry too much about Ems. So let's finish up by adding to our CSS unit summary card. In this chapter, we looked at Rems. We saw common use cases for Rems include text, margin, and padding. And again, the power of using Rems is that when we get to the responsive design topic and learn about media queries, we can instantly change these values by changing the HTML root element's font size for different screen sizes. And this will automatically adjust the text margin and padding properties. Now, pixels, percentages, and Rems are more commonly used. And we're going to be using these throughout our Quill application. There are also properties which are used for specific cases. Ems is an example of one of these. Applying Ems to margin and padding is a common use case. But again, Rems are totally fine, and will make things a lot simpler as we start out. Alright, so let's go add Rems to the Quill homepage. So we're going to go update anytime we're using pixels for fonts, margin, and padding. So all font sizes will be changed to Rem, all paddings will be changed to Rem, and all margin will be changed to Rem. So all we're going to be doing now is updating a whole bunch of values, so we can use Rems moving forward. So I'm back inside the app.css file of our project. We're going to scroll down, and the first thing I need to do is select the HTML root element. We always want the universal selector to come first, and we're going to pop the HTML root element underneath this. Like we saw earlier on, we're going to set the font size to 62.5%. This is basically the same as 10 pixels, and as we spoke about earlier, this is better practice because if someone updates the font size in their browser, like my mum, to something much larger, we're not overriding that value with, say, a font size of 10 pixels. So that's the first thing we need to do. Now we need to go change a whole bunch of pixel values. I'm also going to be highlighting values we don't want to change. In the container, 1200 pixels, we don't want to touch that. We only want to be applying Rems to things which we do want to scale. The reason we have max width at 1200 pixels is for much larger screens. As soon as we start moving down to smaller screens, we want to use Rems. But for a large screen size, there's no need to apply Rems because it's only being used for one case, and that's to ensure our content doesn't spread too wide on larger screens. Anytime we're using small values of pixels, like letter spacing, there's also no point in using Rems, so we're going to leave this as -2 pixels. All the font sizes, we definitely want to update to Rems. So I'm going to change 62 pixels to 6.2 Rem. 48 pixels will now become 4.8 Rem. 40 pixels will become 4 Rem. 32 pixels, 3.2 Rem. 24 pixels, 2.4 Rem. Now for our paragraph, we're also going to update this to 2 Rem. Our anchor tag will be 1.6 Rem. Our small text also needs to change to 1.2 Rem. So we've updated the global styles. Let's now go update our different components. The font size in the button, we want to change to 1.6 Rem. The padding we want to change from 15 pixels and 30 pixels to 1.5 Rem and 3 Rem. The border radius of 8 pixels, we're just going to leave. As we've seen earlier, border radius is a property we just keep in pixels. It's such a small value that Rems has very little significance. For the different states of our button, we can see 2 pixels is being used on the border. And again, we're not going to go change that. It's such a small value. For the highlight, we're going to update the padding here to 0.5 Rem and here to 1 Rem. Again, border radius we're not going to touch. Now for small images, like our logo, medium and small, we're just going to leave those as fixed widths in pixels. As we saw in the guidance earlier, we continue to use pixels for logos and icons. Let's now go down to the different sections of our page, where we'll be changing a lot of margin properties. We'll change our 200 pixel value here to 20 Rems. In the hero section, this will now become 30 Rems. 10 pixels will become 1 Rem, and 50 pixels becomes 5 Rems. In the features section, 300 pixels will become 30 Rem. The margin bottom here will now become 8 Rem. 20 pixels will change to 2 Rem. And again, the max width here, I'm just going to leave at 400 pixels. It's the exact same guidance with our container. When using max width, that's just ensuring an image doesn't go too big for a certain screen size. As soon as we reduce the width of the browser, that disappears anyway, and width 100% takes over. So we don't need to apply Rem values for max width. Going down to our CTA section, we're going to update 300 pixels to 30 Rems, and for our CTA card, we're going to leave the max width at 1000 pixels, but we'll update the padding to 10 Rem, and over here to 20 Rem. The border radius, again, we're just going to use pixels. Scrolling down, we're going to update 30 pixels to 3 Rem. And in our footer, we're just going to leave the width of this social media icon at 20 pixels. So let's check this out in the browser. So there's been absolutely no change. All I've done is updated our pixel values to the equivalent Rem value. If I open up DevTools, let's click on the heading. You can see its font size is 6.2 Rems. If I go to Computed and check the font size, it's 62 pixels, which was the original font size we set using pixels, but we've now changed to Rems. So all we've done here is updated font sizes, paddings, and margins to Rems, so that when we get to the responsive design topic, when we use media queries, all those properties will be updated when we update the font size of the root HTML element for different screen sizes. Now, just to give you a taste of this, currently the root element has a font size of 62.5%, or 10 pixels. If I update this to say 50 pixels, which would effectively be 50% times 16 pixels, or 8 pixels, watch what happens as I refresh the browser. All the font size, margin, and padding has now scaled. Let's change this to a much smaller value, like 20 pixels. Okay, again, you can see all the margin, padding, and font size has all scaled down. Now this obviously looks awful, but I just wanted to demonstrate that by just updating this single value now, the font size of the root element, it automatically updates all the padding, margin, and font size within the design. Okay, let's just change this back to 62.5%. Finally, we'll learn how to size elements relative to the viewport with VW and VH. We'll be discussing what are VW and VH, and we'll look at some VW and VH design guidance. So what are VH and VW? View height, VH, and view width, VW, are units that are a percentage of the browser's visible window. So they're kind of like percentages that we've seen earlier, but VH and VW are specifically a percentage of the browser, whereas percentages was based on some parent element. So let's say we have our browser, which currently has a height of 1800 pixels and a width of 3000 pixels. We could have an element shown in red, and we could define its height as 80 VH, which would equal 1800 pixels, the height of the browser, times by 80%, which would give us a value of 1440 pixels. We could give the element a width of 50 VW, which would be 3000 pixels, the browser width, times by 50%. This would equal 1500 pixels. So once again, we're defining the element's dimensions, its width and height, based on the browser's current width and height. Now, of course, the browser can change in both width and height. As a user, you can always go and change the dimensions of your browser. So let's say we now reduced our browser in both width and height. The browser now has a height of 1000 pixels and a width of 2200 pixels. The element's height was defined as 80 VH, which is now 1000 pixels times by 80%, which would be 800 pixels. For the width, we defined it as 50 VW, which would now be 2200 pixels times by 50%, which equals 1100 pixels. So you can see that as we change the width and height of our browser, the element is changing based on the VH and VW values. So let's play around with this in VS Code. I've got the boilerplate HTML, and I've gone ahead and linked a style sheet, which is currently empty. So all I'm going to do is add a single div. Let's head over to app.css. I'll select the div. Let's give it a width of 60 VW and a height of 40 VH. And just a reminder, VW stands for view width and VH stands for view height. And finally, let's just add some background color of light blue. I'm also just going to use the universal selector to remove all padding and all default margin. So let's check this out in the browser. So currently my browser is the full width and height of my screen. So let's open up DevTools. We'll select the div. I'm just going to scroll this up, and you'll even see as I'm scrolling this up, the height of the div is reducing. You can see in the top right corner, the width and height of my browser. So I'm just going to go land at a nice value like 300 pixels. So right now, my browser is 1280 pixels by 300 pixels. Let's go look at the box model. You'll see that the current width of the element is 768 pixels. We defined our width as 60 view widths. So it's going to be 60% of the width of the browser, which is 768 pixels. We defined a height of 40 view heights, which is 40% of the browser height, or 40% of 300, which would be 120 pixels. I'm going to now change the browser width, and you can see the width of the element is also reducing. So it's always 60% the width of the browser. I could also go to the bottom of my browser and reduce the height there. And you can see as I move around, the element is always scaling based on the view height and view width I defined. So let's now take a look at some VH and VW guidance. VH can be used on hero sections in conjunction with min height, so content is always above the fold. Now, above the fold just means it's the portion of the page you don't need to scroll for. Above the fold comes from the newspaper industry. When newspapers are folded, it's the top section of the newspaper. That is, the most important content you want your readers to see straight away. So what we could do is on our hero section, define a total height of 100 view heights. And what this would do is that ensure that this content is always above the fold, so that no matter the height of the browser, you'll always see this content. And this is one of the few instances we set height on a main section. For sections, we usually never set a height. The height of a section is usually defined by the content height and any padding and margin. It's very rare to actually set the height of an entire section, but this is one example where you might want to do it. So I'm on the Duolingo homepage here, and you can see above the fold we have our navigation, this main hero section, and this banner of different languages you can scroll. Now watch what happens when I reduce the height of the browser. All of the content, including that banner at the bottom, is remaining above the fold. There's no additional scroll that's being added hiding any of this content. Eventually I do get to a height where this breaks, and you can see now it's going below the fold, and I have to scroll. So view height is being used here to ensure that until a certain height, all the content is remaining above the fold, and that at a certain point, a minimum height is being set. Because if you were to make your browser height really small, you wouldn't want all the content being forced into this small section. So view height is being used in conjunction with min height. Just to contrast this with another homepage, this doesn't have view height defined, so that when I reduce the height, you'll see the content just goes below the fold. So let's look at some more guidance. VW can be useful for creating responsive text when it is a main standalone element and not confined within a container. Looking at this page over here, this text is fully responsive. It's not within a container, and as the browser width reduces, the text width also reduces. Let's check this out in the browser. So I've got the page up at full width, and as I reduce the width of the browser, you'll see the text also reduces in width. So let's finally finish off our CSS units summary card. VH and VW are both used for specific cases, so I'm putting it in the red box on the right. For VH, it can be used for defining a section height, which we saw on the Duolingo homepage, and this is totally design dependent. As I mentioned, it's much more common for your section height to be defined by the height of its content and any padding and margin. But you can use VH on an entire section to get the above the fold effect. For VW, we saw we could use it on text, but in all honesty, this is not very common. So I really wouldn't worry too much about it. I did just want to show you a use case. All right, so let's go add view height units to our Quill project. Like we saw earlier in the guidance, on our Quill project, I want our entire header, which includes the navigation bar and this hero section, to always be above the fold, so that when I scroll up, the content isn't cut like this. Now I'm going to give a bit of a heads up. We are going to go implement the view height units, but at this stage of the course, it isn't going to work because we need to master Flexbox first. But let's go set this up. So I'm back inside our index.html file. And as I mentioned, I want all this content inside the header to always be above the fold. So let's go add a class here called header. In app.css, I'm going to scroll down to the different sections. I'll copy this and make a new section called header, which is essentially our nav bar and hero section combined. I'll grab the class header we just defined, and I'll set its height to 100 VH. So let's check this out in the browser. So if I come and scroll up here, you'll see that the page is still being cut. That's because we've defined some margin bottom on our navigation and margin bottom on our hero. Looking back at the CSS file, you can see on our nav bar, we have margin bottom of 20 rems, and on our hero section, margin bottom of 30 rems. Now, adding a height of 100 VH doesn't override that. That margin is still there. For this to work, we need to learn about Flexbox, which is coming up in a few topics' time. Flexbox is the modern approach for laying out containers and elements on your page. And once we implement Flexbox, the height of 100 VH will work. Now, I do want to show you a problem that has been introduced now that we've added height of 100 VH. If I scroll down, you'll see the content from the section below is coming up here. It's kind of like floating above our hero section. Now, the reason this is happening is because we've now defined the height of our section as 100 VH, which is 100% of the current browser window. So all that this content below sees, from its perspective, is the current height of the browser. So it thinks just to start over here. And if I scroll up further, the section below now thinks the height of the header above is just this height. So it will now start immediately over there. So to fix this, we need to also go add a minimum height so that the header is able to always maintain a minimum height. And if you remember, I mentioned we would implement this towards the end of the previous topic. So let's go do that now. Back in our app.css file, I'm just going to go add a min height, and we'll set the value to 800 pixels. So this will now ensure that the minimum height of the header is always 800 pixels. So let's refresh. I'm going to reduce the height of the browser. And if I scroll down, you'll now see that this content is only starting here, which would be 800 pixels from the top of the browser to the start of this section. So I know I may seem a little bit disappointed that we've learnt all about VH and it's not working just yet, but we need our layout to be more fluid, and to achieve that, we need to implement Flexbox, which we will be doing soon. That's all for CSS units. Well done on nailing these crucial concepts. In the next topic, we'll dive into CSS functions, exploring how to set up reusable values and perform dynamic calculations, which help us create more flexible and efficient CSS. Also make sure to subscribe to the channel to stay in the loop with new releases. See you in the next video.